Let's try some examples of finding the domain algebraically. Find the domain of the given functions. The first one is f of x equals x plus 3 over x squared plus 8x plus 7. So anytime you're asked to find the domain algebraically, you compare it to this list and you find any numbers that it's going to violate these rules. So, in part A, do we have a possible division by 0? Yes, because we have a fraction and there's a variable in the denominator. This type of function is what's called a rational function. Rational is just fancy talk for fraction. To find the domain of a rational function, you figure out what numbers are going to make the denominator 0, and then you tell the viewer, I don't want those. So you set the denominator equal to 0. So we're going to say x squared plus 8x plus 7 equals 0. How does x squared plus 8x plus 7 factor? Mike, I have a problem with factoring. Okay. You have 1 week to correct that issue. If you have issues with factoring, watch my Math 1200 videos on factoring, because you need to do it. We're going to have a whole chapter dedicated to it. And by factoring, I'm talking about crazy go nuts factoring. We're going to learn how to break down 5th degree polynomials using only our feet. It's going to be awesome. If you set each factor to 0, what does the first factor say about x? And the next one? And I think I already heard it. We don't want these values, so how do I tell the viewer? No. There you go. Put a slash through it. Now for me, leave your answer like that. If you want to be fancy, pinky out. Negative infinity to negative 7, union, negative 7 to negative 1, union, negative 1 to infinity. How much fun was that? Not at all. Leave your answer like this. I'm totally fine with that. The book, on the other hand, is going to write this. Too rich for my blood. Good to go. Questions on part A. Part B, g of x is x cubed minus 7x plus 1. Go through your list. Are there any fractions? No. Are there any radicals? No. Are there any, we don't know what the third one is, say no. No. So are there any numbers that we cannot put in for x? No. So what's the domain? All real numbers. Nothing to worry about. I'm just going to write it up there to save room. Does anyone know what family of functions, I'll be right with you, that part B is in? Close. No. What family is a cubic in? It means many terms. Polynomial. Polynomials are what you start with in mathematics because they are the nicest family of functions. Everything behaves as expected. And then you go on to the icky, sticky ones like this guy. And that one's even worse over there. That doesn't even have a name. Wah, wah. The third one is a hybrid between the first two rules because we have a possible division by 0 and we have a possible square root of a negative. So here we go. According to the first one, we cannot divide by 0, so the denominator can't be 0. The denominator is only going to be 0 if x minus 9 equals 0. Is that okay? Okay. 2, can't take the square root in this case of a negative number. Well, that means that x minus 9 can't be negative either. So if it cannot be 0 according to the first issue, and it cannot be negative according to the second issue, then the radicand must be greater than 0, must be positive. So if it can't be negative and it can't be 0, it must be positive. You solved it right away, which is fine. But in general, the radicand has to be greater than 0. Now this one's a nice one. How do we solve for x here? Add 9. So the domain is all values of x such that x is bigger than 9. So if you picked a number smaller than 9, you'd be taking the square root of a negative. That's bad. If you picked 9, you'd be dividing by 0. That's bad. Everything else is a-okay. If it was just this guy, if that was the function, then the only thing you would have to worry about is the radicand being what? Negative. So in this case, you could say x minus 9 is greater than or equal to 0. Because you can't have a square root, the radicand equal to 0, because what's the square root of 0? 0. So this is okay. So notice the difference. This would be x greater than or equal to 9. But as soon as it went downstairs, we can't have it equal to 0. Because that would be bad. Bad.